Well, hello, I'm Robert Daly with Sun and Steel Solar, and I want to show you how we're going to build solar farms without rolling down the aisles. We use the round torque tubes as trolley rails to install the torque tubes themselves, as well as all the photovoltaic modules. This is a solar farm with 100 rows. Each row is 70 meters long, 5 meters wide. The aisles are 5 meters wide as well. I'm going to show how we're going to build this out without rolling down the aisles. On the left, it shows us rolling down the aisles with the industrial PEZ machine dispenser, spitting out 2P modules at a time, 2 in portrait. Over on the right, it shows using the trolley rails, or excuse me, the round torque tubes as trolley rails for a shuttle that's carrying down or shuttling down pre-assembled 2P. This is an old drawing just showing a combination of shuttling and the pick and place machines. This is for 4L, 4 in landscape. This is a typical solar farm of 1 megawatt, 16 rows with crushed rock roads, accessible roads on the end. If you drive down those aisles, it could be perfect, it could be horrible. So here's our 16 rows with all the posts in place. Why would we want to use the torque tubes as trolley rails? Because it's faster, better, cheaper, and safer. It could be that the aisles are muddy or icy, full of snow, just dangerous. They could be planted with crops already, and we don't want to tramp on them, or environmentally sensitive land, and we don't want to tramp on that. So we're going to take 1/4 megawatt at a time. We're going to build 4 rows at a time. Here's those 4 roads, the access roads on the left. Here's all the posts in place. And we're going to put these pre-assembled torque tubes. They're 22 foot long with the bottom journal coupler on the bottom, the magenta piece on the right. That's what rubs inside our bearing race. This is our bearing race showed on the right or on the left. It's just a simple steel on steel bearing. We don't have no plastic bushings. We can put a plastic bushing puck in there if needed, but this allows transfer of grounding electricity, and it doesn't squeak. It turns slowly, 22,000 times back and forth over 30 years. It does not wear out. We've done all that testing. The journal fits in there like this. It's unstable as shown, but this is what's going to rub on the bottom of that bearing race. And it really comes together as a torque tube assembly system. So this is now stable. This sits in there in that cup loosely. It's not a tight fit. It's just a guide. Then the next torque tube system goes on. At the other end is a journal coupler that sits right into the next post and onward. This is a whole system. 2 torque tubes are joined together with a gap in between. The top and bottom journal couplers, which are magenta, have a gap in between, and it creates a window on each side for our takeoff cables of our winch and rigging drive, distributed wind hold to exit. Here's a 1/4 megawatt of post. Over on the left is a pick and place machine. Imagine that blue rectangle is a pick and place machine. We're going to have 2 shuttle carriers to shuttle the torque tubes and the PV. Again, the torque tubes are pre-assembled. They are on the cargo shuttles shown on the left. Those shuttles will also carry the PV. We recommend up and down 2P for balance. The one on the left shows the monofacial. They're right over the torque tube. But the one on the right is bifacial. It's picking it's picking light up from the ground reflection. So you have to pull it off of the torque tube, and then it doesn't get shaded from underneath. But these are balanced. The picture on the left or in the middle shows two 2Ps tilted, and it is balanced. It's not top heavy. I can turn an entire row with my hand. Over on the right is how it would be stowed during winds. The wind is always hitting the top side, not trying to lift it up. Or if it's raining, the rainwater will sheen off quickly and not leave sediment ponds. So let's get going. We are prepared. We're going to take the pick and place machine and put down the first 2 torque tubes, lift the pick and place machine up and set it on those torque tubes. Now we put on the next 4 torque tubes, move on down. Now we want to put on the end caps, the top of the bearing race. It's not a top bearing race, it's just a cap to keep the wind from blowing the PV off. Remember, our bearings, our journal is loose inside that bearing race. It's not a tight fit. It's a very forgiving, tolerant, and just a guide. We now lift up the cargo shuttles, put them on, and now we are going to put the next 4 torque tubes, move on down, next 4 torque tubes, and we just keep moving on down. Eventually those shuttles will get empty and they go back to pick up more torque tubes, and we continue all the way down to the end, and we have 2 more torque tubes to add, and that would be the first and the last. Now we're ready for PV. Each of these bearings have a lock mechanism for temporary hold so that the torque tubes won't turn. The bottom bearing race is always in the bottom. This is a time to put in our winch and rigging drive. The rigging goes inside our torque tubes. It can be delivered from either side, but now we have a complete torque tube ready to take our pole chains. It's like pole rods, but the chain lengths are 22 foot long. Remember, this is a time to put in the rigging. On those 6 outer post bearings, they are now ready for the bearing caps. We put those on so those bays cannot be blown off. Put on the first, the second 2P, fill up that bay, fill up that bay. Now let's move on down. We can move over the bearings because we can roll over them because they haven't had the bearing tops on yet. We put on the next 4 bearing tops, and now those bays cannot be blown off. Once we put on the PV, another bay of PV. Roll on down, put on the bearing caps. Load the PV up, put on the bearing caps after we move down, and we continue the process all the way down, and the shuttles will keep going down to the end, the starting point, to pick up more PV for loading. Here we go all the way down, and we're just about to the end. Attach those bearing caps, put on the last bit of PV. Now we're going to remove the cargo shuttles, move the pick and place down 1 more, and put on the very last 2 bearing caps. Load up those last 4 bays, next to last. Take off the pick and place machine, load up the last 2 bays, and we are complete. We have a 1/4 megawatt completed, ready to move on to the next 4 rows. It can be done simultaneously on other ends as well, in other places. There is a way to link these 4 rows to make them very long with a temporary bridge so that the shuttle and pick and place can go all the way down 2 lengths of rows. But that's 140 meters of shuttling. Maybe it's too long, TBD down the road. But this is the faster, better, cheaper system of EPC, Engineering, Procurement, Construction. I want to thank you very much for listening, and that's the end. Sun and Steel Solar.